the continuation of this millikan World experiment, and before this one we started to make figure and that experimental mental setup that we had shown before, and now we are in the theory. You know how mathematical expression we can get from their millikan World experiment. Here is all description about that. Let me describe this. First of all, let's get started. Here is theory 1 and theory 2. In theory 1, I am going to discuss about the this whole phenomenon without the electric field. When electric field is not given, what happens in it? We study about it. First of all, look at this figure. Here are the two forces, upthrust and viscous, which are in upward direction, and the weight of this wall drop is downward direction. When it has the terminal velocity at that time, you can see this condition. These two forces, F plus U, that means viscous force plus upthrust, they are in upward direction, and the weight which is in downward direction. These two when becomes equal, then only the this wall drop attain terminal velocity V1. Here is suppose the electric field is not applied. Here is not electric field. As the wall drops falls under the gravity को under में wall drop तल खस्दाखेरि के देखिन्छ, the velocity goes on increasing. You know, the every time velocity goes on increasing of this wall drop. A stage comes when the viscous force on the wall drops become equal to its resultant weight. भन्दाखेरि एउटा स्टेजमा पुग्छ जुन स्टेजमा भिस्कस फोर्स चाहिँ र अपथ्रस्ट जुन चाहिँ वेटसँग इक्वल हुन जान्छ. लेट मानौ v1 चाहिँ टर्मिनल भेलोसिटी छ, रेडियस चाहिँ r छ of this wall drop, m is the mass of this wall drop, rho is the density of this wall drop, and sigma is density of air. And then when we apply this formula at F plus U equal to W, which is the weight, and you can see where F is the viscous force, which formula is 6 pi eta r V1. This is in a class 11 2, and this means this is the viscous force in between any two liquid. You know, the liquid molecules, they are together because of this viscous force in between them that holds them together. That viscous force is 6 pi eta r V1. In the place of F, we can write 6 pi eta r V1. In the place of U, this is upthrust. Air also pushes this wall drop in upward direction, and which is equal to weight of the air displaced, and the weight formula we know mg, m equal to v into rho, volume into density into g. In the place of v, we write 4 by 3 pi r cube, and here is v, and rho is as it is, g is as it is. And the next one, in the place of a weight, you can see the weight of a wall drop, w represent, and which formula is here, mg, and m equal to volume into density. So in the place of a v, we can write same as we have written here, and 4 by 3 pi r cube rho g, rho g. And when we substitute, when we put all this value of this f, u, w in this equation, then that would be like this one. You can see here in the place of f, I have written 6 pi eta r v1, in plus is plus as it is. In the place of u, you can see 4 by 3 pi r cube sigma g equal to, in the place of w, you can see 4 by 3 pi r rho g, because we have calculated all this value. And when you take these two in a right hand side and left hand side, and the other part in the other side, then you can get this expression r equal to under root 9 eta v1 divided by 2 rho minus sigma g. This is the what? Radius of wall drop. And the next one is this is the whole calculation for radius of a wall drop. Wall drop को radius को लाग्यो. And the next one चाहिँ theory 2 छ. Theory 2 मा चाहिँ motion of a wall drop under electric field. Electric field मा चाहिँ electric field apply गर्यो. यहाँ चाहिँ electric field apply थिएन. Here wasn't electric field. Here is electric field. What happens? अब त्यहाँ electric field हुँदाखेरि हेर्नु त यहाँ चाहिँ इलेक्ट्रोस्टैटिक फोर्स पनि आउँछ. त्यो चाहिँ इलेक्ट्रोस्टैटिक फोर्सले माथि धकेल्छ, अनि किन त इलेक्ट्रिक फिल्डले इलेक्ट्रोनलाई माथि धकेल्ने भन्छ, अनि अपथ्रस्ट पनि माथि नै हुन्छ, अनि भिस्कस फोर्स चाहिँ तल हुन्छ, अनि w पनि वेट पनि तल हुन्छ. त्यतिखेर टर्मिनल भेलोसिटी सपोज v2 छ. अब यहाँ चाहिँ when electric field is applied, the wall drop starts moving upward. You know the at a time when you apply electric field, at that time wall drop starts moving upward, माथि माथि जान थाल्छ, and soon attains terminal velocity v2 in upward direction. Upward direction मा v2 velocity attain गर्छ. अनि त्यसपछि लेट मानौ चाहिँ E equal to electric field, Q equal to charge of that wall drop, then the electrostatic force it experience F equal to QE, which is the formula of electrostatic force. You can see here, and the viscous force, which is due to the terminal velocity v2 equal to here 6 pi eta v2, And this expression you can get from here. You know the W equal to 4 by 3 pi r rho g here is, and W u equal to this one. When you put these two value in this place, in the place of W 4 by 3 pi r cube, in the place of u 4 by 3 pi r cube, these two common, and you would have the expression like this. And then when the V2 terminal velocity, then Fe plus u, because Fe plus u in upward direction is equal to F plus W in downward direction. And when you take this u upthrust in this part, then you can write this way. You can see here W minus u plus F, and Fe as it is in the place of Fe. QE I have written from here, QE in the place of Fe, and W minus u equal to 4 by 3 pi r cube rho minus sigma g. So I have written this value, rho minus sigma g equal to which value, 6 pi eta r भन्नु भनेको यो W minus u भन्नु भनेको नै f सँग बराबर हुन जान्छ। त्यही भएर यो भ्यालु चाहिँ जो W minus u छ नि, यो W minus u भनेको चाहिँ यहाँ देख्नुहुन्छ W minus u गर्यो भने यो f सँग बराबर हुन्छ। भनेपछि योबाट यो घट्यो भने यो सँग बराबर आउन सक्छ। त्यही भएर त्यसको ठाउँमा u माइनस, यहाँ चाहिँ W minus u को ठाउँमा के लेखे, 6 pi eta r v1, किन त यहाँ आइरा छ नि त यहाँ एक्सप्रेसन 6 pi। अनि यो f को फर्मुला चाहिँ के छ यहाँ अगाडि, यहाँ 6 pi eta r v2, and here 6 pi eta we can take common r as well. So here is q equal to, as it is q we divide in this part. At last you can see q equal to 6 pi eta v1 v2. v1 is terminal velocity without electric field, v2 is terminal velocity with electric field. E is electric field, you can see, and in the place of r we can write 9 eta v1 divided 2 rho minus sigma g. From this equation, this is the second equation, which is the what calculation, which is the charge of world drop. In this way, charge of a world drop is obtained in this world drop, in this millikan world drop experiment. This is the last expression. This theory 1 is for without electric field, this theory 2 is for with electric field. And how much charge with the world drop? Q equal to 6 pi eta v1 plus v2 divided by e under root 9 eta v1 divided by 2 rho minus sigma g. This formula we use to calculate charge with electron or world drop. World drop सँग भएको चार्ज चाहिँ निकाल्न सकिन्छ। That's all for today.